Hello, YouTubers. A while back, I walked you through building acceptance tests, end-to-end testing for ASP.NET Core API. We went through the entire process of, setting up a storage broker and a service and a controller, and then we went on to build an acceptance test, which, acceptance tests happen after the fact, after you've actually developed the systems and you have APIs and controllers running, in the opposite of building unit tests where it has to be driven first. You write the unit test and then you make it pass. And just a quick reminder here, the video was mainly about building ASP.NET Core applications. Let's go ahead real quick here for the video. So building end-to-end acceptance test testing, and I remember, we were talking very extensively about, building all of these components, within that schooling system, right? So, we built a storage broker and we're trying to write a unit test for it and so on and so forth. And I put a little bit of details about the source code for this in a SchoolM project, where you can see very clearly here the student's API would go and try to hit the API endpoint, post a student, create a random student, and then try to post a student, and then get student back by ID to verify whether that student have actually been persisted in the storage that this API owns or not. This is all fun and games and great, right? But as long as it only works as long as your API endpoint actually owns these resources. Like you have a local database that you can actually, provision and hit. It makes it so easy with using the entity framework, to actually provision, up and down, provision and deprovision a database on the fly and run a test within few seconds. But it's not always like that. If you're building a truly industrial enterprise level applications, you know that you will run into situations where you need to actually integrate with external resources that you don't necessarily own. So let's put a little picture in here just to visualize things. In the original SchoolM end-to-end ASP.NET Core end-to-end testing, we went and said, okay, this is my SchoolM API project, and I have a little database in here, and I am able to go write an acceptance test that goes, so let's say this is my acceptance test in here, and my acceptance test is going and saying, okay, let's create all our resources through the API. Let's exercise all our resources through the API. And I already own this database, so it could be a local database. It could be the database that is already running in production. It doesn't matter because I have all the API endpoints to be able to kind of test this functionality and make sure that I have full control and full manipulation over the database. But let's imagine this for a second. Okay, you verified that SchoolM acceptance test, it's working fine, this guy is good, this guy is good, and the acceptance test is saying, yep, you are good to go. Now imagine this, imagine that, another client, was not necessarily own SchoolM API. And let's say this microservice is called SchoolX. And SchoolX wants to integrate with SchoolM, right? But it also wants to have acceptance tests. So what that basically means, our acceptance test now is in trouble with the model that we've explained about a year ago. Your acceptance test has absolutely no control over calling, an external API endpoint and trying to create and remove and update resources in it. In fact, actually, it would be naive to think that creating a resource in an API and then calling a delete would actually delete that resource. Most of, APIs, they normally don't really delete off the bat. They soft delete, meaning that they would go and say, I'm just going to mark a particular record as deleted, but it's not actually deleted. It's still in my system. So how do we go about fixing this problem, right? I have to talk to you a little bit about the theory first, and then we will talk a little bit about the implementation, and hopefully you will love the implementation because it's really simple. I'm so glad, I had the ability to kind of put together, a little solution using some really, really innovative ideas, and innovative solutions some engineers, some really smart engineers around the world put together, to solve problems like these. Okay, let's step back a little bit. There's this huge thing on the internet that you would hear about, something called Pact, Pact APIs. And Pact was basically a proposal originally to be able to kind of create a contract. And this contract, let's say you have a consumer and a provider, and there's a contract. And what Pact is doing is that it's mimicking the behavior of an external provider that you don't necessarily own, right? So let's just move forward a little bit here with Pact. I want to show you, what does that really mean? Okay, Pact basically mocks an existing consumer that you may have, an existing provider that you may have. So assume this is your consumer and you have your unit test. They call it a unit test. It's really end-to-end because it's testing all the little components in your system. But instead of actually calling the real provider, right, it's calling a mock of that provider. So you're basically telling your API, hey, I want you to believe that there's an actual corresponder on the other end of this API, but there actually isn't. It's something that I have manifested, temporarily to convince you that there is something out there. If you think about it, it's exactly the same idea when we do mocking, right? Like if you have a service like this, let's say you have student service, right? And student service has dependencies on two other brokers, right? Let's say you have a storage broker and you have the logging broker, for instance, right? And you want to test just the student service. What do? We go and say, okay, you're calling these dependencies. I'm gonna mock these dependencies. So these two are mocked, and then I'm actually gonna test this. So in reality, when you're writing a unit test, you're not really hitting the actual database. You're just seeing how your service would behave, assuming there are different behaviors and different situations and states where your database is behaving. Okay, so on the lower level, on the unit test level, you're going and mocking, a local dependency. So if we go a little bit further here and say, okay, so if I have in my system here for your unit test basically doesn't really care about external dependencies. It goes and says, mock everything around me. So if these are your brokers, and these are your services, and these are your controllers, your unit test basically goes and says, mock this dependency here, completely mock it. I don't care about it. And focus more on this one here. So the subject of focus here would be the service. And what it's going to do is that the unit test in here will try to hit the service. This is unit test like this. It tries to hit the service while mocking its dependency, so you're not actually mocking these dependencies. If you zoom out a little bit, the subject of your test becomes the service itself, like the actual service that you're working with. So how would that work? Let's zoom out a little bit from here. So here's your service, here's your microservice. Everything in here is the subject of test. And instead of having, this is what your acceptance test or end-to-end testing is going to be doing, is that instead of having a unit test, you would have an acceptance test. Some people call it integration, some people call it end-to-end, call it whatever you want to call it. And your acceptance test, what it's going to do now, is if it's an external dependency, there are two cases actually. If it's not an external dependency, something your controller owns, like a database, your microservice owns like a database, go ahead and communicate with this database. All power to you, right? But if the service living on the other side is an external resource, an external API, then this is where your acceptance test need and fake an external API running, against your service. So how do we do that? How do we go, fake an external API so when I hit the controller to the service to the broker and actually test my entire microservice, I know for a fact that I'm actually hitting a real, like I'm actually communicating the right information and getting exactly what my API endpoint the external integrations work. So I want to test my integration. I want to test that these components are talking to each other. Here's what I have for you. So I pulled out the original SchoolM service, microservice. And SchoolM microservice, if you go a little bit closer to the controllers in here, you'll see that we offer a whole bunch of capabilities, almost all the capabilities here. So we have the delete, we have the get, we have the get by ID, we have the post, right? There is no modify in here, but there is a get by ID. What that basically means is that if I run my SchoolM microservice and go /students like this to pull out all the students, I should be able to pull out all the students that are in the database. There's only one student, Hassan, that's living in that database. What that basically means, if I do /ID, it should give me back the ID. This is good enough for me. That means on the map here, let's go back to the map up here. On the map here, SchoolM, has an API endpoint. Let's mark the API endpoint in here. So it's /API/students/student ID. So I'm hitting this API endpoint and I'm saying, hit that API endpoint, give me a student by ID. Okay, what about SchoolX? I have built SchoolX for you. I'm not going to build it, throughout that video because I've done it many times before, but I'm just going to show you, what SchoolX looks like. So let's go to SchoolX in here. Here's SchoolX. Let me just walk you real quick through. Let me increase the size here a little bit. I think I am at 150. Let's make it 175. There you go. Okay, I hope this is visible. Let's go back to here. So let me hide this camera here. Oh, there you go. So let me just walk you through the solution here so you understand. I have an API endpoint, and the API endpoint has an iSchoolM API broker. And this SchoolM API broker basically has a method that says get student by ID. The implementation of it is literally an API endpoint where it's calling, so SchoolX is calling SchoolM, right? SchoolX, the client, is calling SchoolM to get a student by ID. Okay, all fun and games so far. And then you have all the little setup, that I have in here. You probably have seen me doing this setup for setting up an API broker while I'm doing Blazor applications. But if you're not really interested in Blazor applications, please go through this code. It's definitely very extensive about creating a simple abstract API client. It's using a little open source library. I call it RESTful Sense. It makes things a lot easier when you're trying to pull things and serialize and all that kind of good stuff. Okay, so far so good. I have an API endpoint I can integrate, and then I have a service in here, a student service that goes and says call that API broker, right, and give me that ID. Of course, ideally, if this is a production code, I would have this wrapped up in a try-catch and all the unit tests and whatnot. But just for the purpose of this demo, I really want you to see, what this is like from an integration standpoint. Okay, so I have an endpoint here. I have a method, a foundation service method here that calls the broker and says get the student by ID. So you're communicating the student ID. And then on top of all of that, I have a controller that receives a student ID and returns the student ID. Now, given that SchoolM project is running, it's running right here, all I have to do is just make sure that my configurations are right. Do I have the right configurations? I have the right configuration right here. So when you run your SchoolM project, you have 44.36.9. I have 44 localhost 44.36.9. Okay, perfect. I have this running right here. Right now, now our hypothesis is if I run this SchoolX API, I should be able to hit the SchoolM API and get Hassan as a student from there. So let's try it out. Here's the ID. So this ID, where did I get that ID from? If you go back here into SchoolM API, you can see that ID right here. That's my ID right here, and it's exactly the same ID here. So is this going to work? Let's hit this endpoint. Let's see what happens. And lo and behold, it's returning back the record that I care about. Which means, in other words, if I go here and say /API/student/student ID, It should give me the exact answer. Where is this coming from? It's coming from SchoolM API. So this guy is hitting this guy, and this guy is hitting its own database, and it's giving you the right information. But how do you write an end-to-end test for that? You don't own this storage. You don't own this API. It could be literally anything. It could be a queue. It could be anything in the world. Let's go ahead and start writing some code to test this, and I hope you actually really find this useful today. Okay. Let's get to business. So I have an acceptance test in here, right? And I'm gonna go ahead and just do very simple things for setting up my acceptance test. We've done this, the last time we've done this video, but I'm gonna do it again just for the purpose of this demo. So let's just go ahead in here in the APIs. Sorry, and I have brokers. Let's build the broker first. Always start with the broker, and let's write API test collection right here. And let's use the out of the box Microsoft testing framework. So this is a collection definition, and this is my name of API test collection. That's my guy right here. And then I need the fixture. So this is iTest collection fixture. iCollection fixture. There it is. And inside that guy, I need a SchoolX API broker. Do you remember last time we were doing SchoolM API broker? Now I'm going to do SchoolX API broker. This guy initializes the world for me. Let's just go ahead and build that SchoolM API broker in here. SchoolX API broker. That's my guy right here. And then I'm going to add a few things in here. So in here, SchoolX API broker, let's just go ahead and say public like this. I'm going to define a few things: private, read-only, web application factory. This is coming from the testing framework out of the box from Microsoft. Here's this guy, and then here's startup CS. The startup CS is coming from the project. It's how you're basically initializing your API in phantom mode. So that's this guy. There we go. Just give it a second there. Come on. Let's give it a moment. There you go. I think I hit the cancel button on that one. Let's give it a second. Visual Studio 2022, come on. 64-bit, let's go. There you go. I'll just give it one more minute. This is a preview version, so don't expect things to just run, but we'll do our very best to see if we can make it work. Okay, let's restart this app. Okay. We're going too fast on Visual Studio 2022. Let's do this again. Cover selected files. Here's my new instance of the project. Okay, here we go. Let's go back to this guy. Let's go back to business. This is the API broker. So what was I saying? I was saying web API factory, right? And I needed to pull this. It didn't recover everything, but let's just pull that guy in. I already have this guy. So okay, let's do startup. And that startup CS is gonna come from the reference. Hope it doesn't blow up again. Okay, perfect. And then web application factory. Okay, perfect. Let's see why this guy is angry. Let's Control KE. Let's pull the reference back on this guy. Install the package. Package installed. Beautiful. And then let's initialize our HTTP client. We need that to kind of run things. So this is base client. I think that's what we called it last time. And then let's go and initialize our iRESTful API factory client, which is basically the RESTful sense library. I'm gonna put that. Let's call that API factory client. There you go. And then let's initialize our SchoolX API broker. So this is web API factory equals. Love the autocomplete, and then this is dot base client equal, right? This dot web application factory dot create client. It knows what to do. And then this dot API factory client will be the new RESTful API factory client with the base client, which is the HTTP client in it. Okay, so this is our test container kind of thing. Takes startup and starts a FIM2 copy of your API. This is your HTTP client, which this guy needs so he can make API calls. That's all that it is. So these are two different things. One of them starts the API under test, which is SchoolX API in this instance. And the other two basically is you're just building an API client. That's all. Okay. Great. Let's go build, the students, part of this API broker. So, SchoolX API broker dot students dot cs. And let me partialize this guy while I'm at it, because we need these instances. We need the API factory client with us in here. Okay, what do I need to do here? So this is public partial class, right? And let's put in the URL. What's the URL that I care about? So here's a constant string relative student API relative URL, something like that. So API/students, right? So that's the API endpoint I need to hit. Perfect. Now what else? I need to get a student by ID. So public async value task. So I need a student model, don't I? We'll put that in here and then we'll create it. And then in here, get student by ID async. And this will be my student ID. There you go. So I need a student model. Let's just go ahead and create a student model. And I always tell people, build the student model externally. Don't use the one that's in your API. So when a change happens, your acceptance system need to notify you that your existing clients will fail because you change an existing model that's in production. It's okay. Copy the model over in your acceptance test. Treat it exactly as if your external guy. Someone might say, why don't I just put it in a NuGet package? Why don't I just put it in a NuGet package and share this across all? Well, there's a couple of assumptions here that are wrong. First of all, assuming that your clients are going to be using the same technology you're using is kind of naive. The whole point of building a microservices architecture is to allow people to build API clients or consumers in any technology they want. It could be Python, it could be Java, it could be anything. That's number one. But then you might come back and say, well, I own the entire architecture, so I know I'm writing everything in C#. The other aspect of this is that, sharing, NuGet packages across your microservices basically is counterproductive and kind of anti-pattern to what microservices is. The whole idea was to keep things really, really separated and completely isolated and domain driven, so you don't have to kind of have single points of failures. I've been in situations where there's some 20, 30 libraries are shared across multiple microservices, and every time a tiny change happens in one library, it breaks your entire architecture across the board. Doesn't sound like a good strategy, and the effort in putting a code that's specific and might be duplicate at the beginning, but the effort in putting that into your other APIs or consumers is a lot less than the time you'll be spending trying to figure out what went wrong, and trying to kind of heal your system. Okay, so here's student. So this is this guy. Okay, so that's your API endpoint, and I want to do an implementation for that guy. So I'm going to go ahead in here and say this dot get student by nope. I want a get. I want a get client in here. So this would be the API factory.get content async. There you go. And my content is going to be a student. And my relative URL will be, so it would be student relative URL for one. And then the second one would be the student ID. And I probably need to await this one. Okay, now it's taken more than 2 lines. Let's just go ahead and break this apart. Sorry, I just scope it rather. You can do Alt Alt up and down, it'll move the arrow for you a little bit, and let's just go ahead and say return here. Okay. So I built a broker API, a broker method that would allow me to go ahead and actually, retrieve a student by its ID. So far, so good. There's no problem there, right? Now, when we actually writing the actual test, this is where things are going to start getting a little bit more interesting. Let's go into the APIs area, and let's just type in a students in here. So it's students. And then under that, I'm going to write in the test. This is where things get interesting. So this is your students API tests.cs. Okay. So what do I need to do here? Well, first and foremost, I need to go here and say public. Usually I keep that as a root file, but because I'm not planning to write all the rest of all the CRUD operations, especially that the API is not offering all of them, I'm just going to stick to, this file. So this is, I want the API test collection in here. This is how you're pulling in this kind of phantom instantiation of your existing startup CS file. And then I'm going to go ahead in here and instantiate my SchoolX API broker. The SchoolX API broker. And then in the constructor, I'm just going to instantiate that. So if you do control period, generate, boom, you have your SchoolX API broker. So far we're building a little acceptance test in here and in the students. So I built the brokers, the things I need to call to run my test, and now I'm writing the actual test. I'm instantiating it. Okay. So far so good. I need to create a random student though on the fly, right? The student has to be really randomized. What I can do, I can build a little, method just like we did last time. So it's private student, and then I can go and say create random student. The student model here is very simple, so I don't have to do much other than install like a Dynamics filler. We need to install this library in here. The Dynamics filler basically helps you generate random values for your input. Someone might say, why can't I just hard code values into my system? Why can't I just go and hard code some student model, and then test it? Well, there's a couple of problems. First of all, I can go and hard code responses in your API, and that will indicate that no calls were actually made, right? So it's kind of a, would make your test give you false positives, right? That your test is passing, when in reality I'm actually hard coding. It's not what you passed in, it's actually what I hard coded in your test. And someone might say, who would do that? Well, the more complex the system gets, the easier it is for people to cut corners. And your tests need to be really, really, really stubborn when it comes to building these systems. So let's generate a random student. Okay, I generate a random student. I think this needs to be static because it's not attached to any state. So that's that. Okay, now let's write a test. What's my test here specifically? My test is that I want to hit my API with an ID, and I need to get a student back from the dependency of my API endpoint. So back to the picture here. I need to test this guy. This is the subject of my test. So all of this is outside of my concern. And all of this needs to be completely mocked away. Like specifically, this guy needs to be mocked away. So it's not actually the real guy that corresponds, instead of a duplicate for it. A duplicate. So this is a real one. This is a duplicate for it. So I'm just going to call it SchoolM mock. How do you mock an API call? This is an interesting topic, right? So we can make this guy pass. Okay. Here's what we can do. Let's go build a test first. Public async task, and then let's go ahead and say should retrieve student by ID async. Okay. Let's put some givens. Let's put some wins and see if we can make this work. Given win then. Here's a random student. So student, random student. Create random student. There it is. And student again, retrieved student, retrieved student. That's from random student. And then the last thing is expected student, which is from the retrieved student. Basically, we define these variables in that particular way so you are able to go and see and say, okay, I know the story now. I know that he's going to retrieve a student, and whatever he's going to retrieve, that's going to be his expected. Okay, so far so good. We also need an ID. We need to use an ID to hit that API endpoint, right? So let's go ahead and say student ID. Just to stay consistent for all intents and purposes, let's go ahead and say, you know, this random student, give me the ID of it, and that would be the student ID, the input student ID that I want. Okay, let's call this input student ID. Input student ID. Okay. Ideally, you'd think, like, if you run your acceptance test at this state, right? Let's just clarify things. If I go here and say student actual student await thus this dot API student API broker dot get student by ID async, and this is input student ID right here. This will only work as long as the API endpoint that you're talking to is alive. But if that API endpoint is dead and you don't own it, and it doesn't make sense that you call it every time you run a test because of authentication, IP blockage, so many different things, whitelisting, blacklisting, all these kind of things, it doesn't make sense that you run that. But I'm going to show you that for a second in here. So actual student should, and this guy of course is going to fail because you don't know if this student is there, right? We probably need we need fluent assertions as well while we're at it. So it is fluent assertions. There we go. Okay. Okay. So let's go up in here. And let's say this should be equivalent to the actual student. Okay. So whether the API endpoint is running or not, really, sorry, it should be equivalent to the expected student. Whether the API endpoint is actually running or not, that's not going to help you here because you don't know what student actually exists in the system, right? If I go and run this guy, Control RT like this guy should fail. Let's take a look. Here we go. Give it a second, and the result is that this guy's failed. Why did this guy fail? Because I think it actually tried to hit the actual endpoint, and it received an HTTP response server error, HTTP request, no connection could be made because the target machine kept refusing it, right? It's basically saying, you know, you're actually trying to hit the real API endpoint with your acceptance tests. Your acceptance test should be only focusing on, or for a microservice, it should be only focusing on the microservice itself and not actually try to go outside of that domain and call. What if you're basically calling a send grid, like an email service or something? What do you think is going to happen? You're going to start sending emails every time, you know, you try to run an acceptance test. That's just unrealistic. If you're in a team of 8 or 9 or 10 or 11, you know, and each and every one of them is running an acceptance test, you're going to run out of budget, you know, consuming external APIs before you know it, especially if it's per request or subscription and stuff like that. Okay, so that doesn't solve my problem. And even if you know the ID, and even if you have the right configurations, there's no guarantee that this API endpoint will be running. And in general, when you're writing both unit and acceptance tests, you should be ready to run in airplane mode. Integration tests, when you're writing all the microservices together, we could talk about spinning up your entire architecture on your local machine, maybe use something cool like Docker or whatever the case may be, sure. But for your acceptance tests, you still want to run in airplane mode. You want to be able completely disconnected from the internet and still be able to run your development and know that your service is doing what it's supposed to. Okay, so what do we do about that problem? It's really simple. It's really simple. This endpoint that we put in here, obviously I know that the other API is probably down. Yep. So SchoolM is already down, right? And even if I run the service, it's not going to work, right? So let's go ahead in here and install. There's this really cool kid, who put together something that's really cool, something called Wiremock. Very, very smart guy, smart engineer. He went up there and he put together, a little library that allows you to actually kind of take control over your external dependencies. Wiremock right here. So if you go to GitHub, here it is. This is Wiremock. And Wiremock basically, gives you the kind of capability to go and control your dependencies. I'm specifically targeting here wiremock.net. Specifically, a special .NET library. There it is, wiremock.net. Right? And I really highly recommend you go and sponsor that guy. He's very, very smart gentleman. And I think it's this guy right here. This guy, Noah Lerner. Noah Lerner. Definitely go support the guy. He built a nice library, very, very nice library that allows you to kind of mock exactly in that Pact kind of pattern. A free library, nice licensing, you can have multiple different kinds of operations, .NET stand and all, fluent assertions, has the fluent assertions right here, RESTful client, it has all the kind of operations that you might need to get up and running. And it's based on Mock4Net, which it's basically mimicking a functionality from Wiremock organization, which is this little website that I was talking to you about. Let's go ahead and install Wiremock and see how things go. By the way, we're running on .NET 6, so this is the latest and greatest, so you don't have to worry about the future. I'm already living there, and I'm telling you this is going to work like a charm. Let's go ahead and install this first, and let's see how things go. Here we go. All right, Wiremock is installed. Beautiful. Now, how do I use Wiremock exactly? Right? Let's go ahead back to my controller here. So this constructor here needs a little bit of work, right? I need to go here and create a Wiremock server that I'm going to be using very soon. So let's go back in here and say private read-only. I hope you can see this. This is this guy, read-only, and then this is Wiremock server. There you go. It's as simple as you might expect it to be. No complications. I've seen some implementations like Pact.net. It just didn't fit in my head. I'm a very simple-minded person. It didn't quite fit in my head. So this .wiremock server, I'm going to go ahead and say wiremock server.start. So I'm starting my own server in here, right? And while I'm at it, it's probably nice to put in a port that is actually reserved for your testing. So I'm going to put in something like, I don't know, what day is it today? It's 6/20/2021. Here's my port. 2021. 6/20/2021. I don't know if you can have a port that big, but probably it would work. Okay. That's my port. Inside that port, now I want to mock my external dependency. I want to go and say this dot server, right? And here's a given. And the given, you can mock a request that would come. See, create request, right? And under that create request, I need to create a couple of things. I need to indicate a couple of things. What kind of request is coming, and it's coming to do what, right? Actually, under that create here, I can go like this and say dot using get. So the request that's coming is a get request. Good. So it's just a get request. I don't have anything else in there. The other thing I need to add before that get request, I need to add the path. The path is, what is that? The path that I'm calling is API/students, like this. And then inside that guy, this is the path, I need to pass in the ID. So I'm basically saying when that input ID is passing through, right? What's going to happen then? I'm going to go down here. Let's break this nicely. Given. There you go. See, the guy this guy Noah, he really made it really nice, really simple and nice and fluent and everything, right? And then we need to do, I think it's the response. So when that request comes in, so this is response.create is response.create. What should I respond with, right? There you go. With body. So I need to respond with something, right? What do we need to respond with? Usually your API is responding with, close the window here, sun's coming in my eye. But usually when your API is responding, it's responding with raw JSON content. Raw JSON content, right? So I can't just say, hey, take my little model and respond with it. That doesn't work. I can't just go and say, here's my model, go ahead and respond with it. I need to return a JSONified version of my retrieved student model, right? I can go ahead in here and say JSON convert and serialize, and here is my retrieved student. So this is that little model that is going to be returned. To make things clean, let's go ahead in here and say, here you go. String retrieved student body. Here you go. So that's the retrieved student URL. And you could, if you want to, you could go and say, I want a specific code. This is how detailed this guy Noah went, right? He basically said you could go and say with status code like this, and it will autocomplete for you. So I think HTTP status code right there, and say OK. There you go. So if you want to test your client, and if you don't want to, that's fine. By default, it's 200. Right? By default, it's 200. And I didn't even need to do get in here. By default, it's all methods, right? But if you want a specific, and I want you to be specific, then this is definitely what you want to go with. Okay, so this Wiremock server basically goes in and says for this path, when you get a GET request, then create a response, and that response will be okay. Gosh, I hate these full qualified. Let's fix that. Create a response. So this is my response. This is my given. This is my then. This is my request here, and I'm going to respond with this retrieved student body. What's left? Something very simple. In your local configuration, just so you're not supposed to have configurations in your local environment anyway. It's like when you're putting in the connection string for your database. Remember in our previous acceptance test, we put the configuration there for a local database, which is not necessarily what's going to happen in production. The same thing happens in here. I'm here saying this is localhost, and I'm basically setting this up for port. What was the port that we set up? 620.20.21. This is my port right here. Okay, perfect. So I have my port, I have my API. I think that's pretty much it. Let's go ahead and run this API and let's see if it's actually responding the way we expect it to. I think I might have missed one thing, but we'll see. There we go, starting to do things. I forgot something. Okay, let's see what it says. Server fade one or more errors, specified argument out of range of valid value. Yeah, the port is too long. Let's change that port number to something simple. Let's just say 622.20. 6220. Let's do it this way. Yeah, I thought that port was a little bit too long. Let's do this again. Let's go ahead and run like this. I don't think it matters if you do allow access to network or not. But let's see what we got here. System net SSL connection could not be established. Oh, is it HTTPS? We probably don't need the HTTPS part. Let's run this again. All right, we have another one. Let's see. Exception, HT response, no matching, mapping found. No matching, mapping found. Let's see what we're missing here. So it's basically saying I did the right call. So this is see the little error that I had here? I didn't do that slash. You have to do that slash right there. That's perfect. Let's do this again. Third time is a charm. Let's do this. Still, nope. Third time is not the charm yet. So let's see. So no matching mapping found. We're probably missing something really simple. API/students. So does my API broker make the right call? This is my student API broker, API/students, and then student ID. So this one is set right. What about my actual broker in here? So API/students/student ID. This is all good. And let's see here. Give me a second there. API students. This should be all good and dandy. We might have missed just a very tiny detail here for this one. Should we do it this way? Probably. Let's see. There you go. Just a little slash. Okay, so slash API students. So this is my API endpoint. I basically set up a port. And now this schooling system, it thinks that it's calling the right endpoint. It's actually thinking that it's actually calling an API endpoint, but it's not. It's calling a fake one, right? That basically we're standing up just to call our API. Just as simple as that. You're basically calling this API endpoint and you're saying, hey, call this endpoint. That basically means if there's any problem in my integration. So let's say, for instance, for whatever reason, I went into my broker here and I said, no, it's not /students, it's /student, like this. Just a tiny change in your configuration. And if you go back and run your acceptance test, this guy should fail because it's saying only when you call that endpoint you'll be able to respond with this value. And then the mapping and all of that stuff. See, this guy is gonna come back and say, hey, I couldn't find this RESTful sense issue response not found exception. I couldn't find a match for what you're trying to run against. Does that make sense? So this way, basically, we solved the one of the most common questions that I received. So Hassan, well, what if you don't own the API endpoint? What happens? Let's say, for instance, and this is going to be the upcoming, sessions to this. What if some people were asking, like, what if you don't, what if you have to put a message on a queue? We don't want to put a real message on a queue, but we want to respond with something. We want the API endpoint to respond with some sort of details and stuff like that. So this is all part of this work here. So anyway, that's pretty much it. If I go back into the map just to visualize things for you, you should be able to see, so we mocked this guy and now we have an acceptance test basically that's passing in our environment. And while I'm at it, while we're in the video, let me go ahead and submit this for you so you can have the so you can have access. So this is SchoolX, demo, mocking external dependencies for acceptance tests. All right, that's not a private repository. Yeah, I think it's all set up. So this is SchoolX. SchoolX basically tries to call SchoolM, and it's basically mocking its external dependencies. I hope that was useful for you. I hope you found that some sort of educational and helpful in any way, shape, or form. Please, if you have any questions, comments, or concerns, feel free to drop a comment in the comment section, and I'll see you in another video. Thank you so much for your patience, and thank you so much for watching. Take care.